Outcomes of hypothesis testing. There are actually 4 possible hypothesis test outcomes. The first 2 outcomes are that we get the hypothesis test correct without error. So in the top left-hand corner, we see where we accept a null hypothesis and the null hypothesis is true. That's correct. However, when the null hypothesis is false and we reject it, that's also correct. And then there's the 2 errors where we do not get the correct answer. The first one is where we reject the null hypothesis, but it was true. That's called a type 1 error. And the opposite is when we accept the null hypothesis when it was actually false, and that's a type 2 error. Now, what's the probability of getting a correct decision or making an error? Well, we already have confidence limits. We've discussed them in a previous topic. So alpha is our significance level. So if we set alpha at 5% or 0.05, which we did before, that means 1 minus alpha is 0.95. So that's a 95% confidence limit. We want 95% confidence limit. Alpha is 0.05. That means we've already specified that we're comfortable of making a type 1 error 5% of the time. That's alpha is not 5%. For the opposite correct decision, the alpha, where we reject the null hypothesis and it was false, the probability is 1 minus beta, which is known as the power of the test. So we want that to be high, obviously, and that means we want beta to be low. So beta is the probability of a type 2 error. It's different from alpha. Now, the importance of these is that in a statistical sample setting, we control alpha. That means when we set our sample, we decide what confidence levels we want to set. We've already looked at how that affects the sample size, and we control that. But the beta we don't control. It comes out afterwards. So once we've set a significance level and we have a sample size, we can then compute what kind of level beta is at. So we can work out what's the probability of a type 1 error and what's the probability of a type 2 error. Normally, typically, say for an alpha of 5%, beta might be much less than 1%, but that's just a rough rule of thumb. The point is that we can reduce beta for the same alpha by simply increasing the sample size. So we set our alpha level, we determine our sample size, we work out what beta is, and then we reset it to get the values that we don't want. And it's important to notice that alpha and beta are in competition to some extent. If you want to keep alpha low and beta low, you have to increase sample size.